Welcome to Get Your FRQ On. This question is from 2015. It is question 1, and it is calculator active. In the question stem, we are given a function r of t that models the rate at which rainwater is flowing into a drain pipe at time t. The model is good for values of t between t equals 0 hours and t equals 8 hours. The volume of rain is measured in cubic meters. The pipe is also partially blocked, and the rate at which rainwater is draining from the pipe is modeled by a separate function d of t. In addition, at time t equals 0, there were already 30 cubic feet of rainwater in the pipe. In part A of the question, we are asked to determine how many cubic feet of water flow into the pipe between t equals 0 hours and t equals 8 hours. The amount of rainwater flowing into the pipe for values of t between 0 and 8 can be found with the integral from 0 to 8 of r of t dt. Since the question is calculator active, use your calculator to evaluate the integral. When we do this, we find that there are 76.570 cubic feet of water that flow into the tank or into the pipe for values of t between 0 and 8. In part B of the question, we are asked whether the amount of rainwater in the pipe is increasing or decreasing at time t equals 3 hours and to provide a reason. Whether the amount of water is increasing or decreasing at t equals 3 hours depends on whether the rate at which water is flowing in is more or less than the rate at which water is flowing out. We can evaluate both rates using our calculator and compare the values. R of 3 is 5.086 cubic feet of water per hour. D of 3 is 5.4 cubic feet of water per hour. And since R of 3 is less than D of 3, the amount of water in the pipe is decreasing at time t equals 3 hours. In part C of the question, we are asked to determine the time t for which the amount of water in the pipe is at its minimum. Water will be at a minimum either at t equals 0, t equals 8, or some value of t between 0 and 8, such that r of t minus d of t is equal to 0 and changes from negative to positive. On the interval from 0 to 8, this only happens at t equals 3.272. We can determine this from the graph of the function. This is a calculator active question, so you should graph it. We are given that the amount of water in the pipe at t equals 0 is 30 cubic feet. And then the amounts for t equals 3.272 and t equals 8 can be found using definite integrals. Since this is a calculator active question, you should use your calculator to calculate those integrals. And the integrals we get confirm that water is at a minimum for t equals 3.272 hours. In part D of the question, we are given that the maximum capacity of the pipe is 50 cubic feet. We are then asked to write an integral for the variable w greater than 8 for when the water in the pipe begins to spill out. For w greater than 8, water will begin to spill out once the amount of water in the pipe exceeds 50 cubic feet. Now, this sounds more like an inequality than an equation, but we're asked to write an equation, so make sure you write an equation. The integral equation we need is going to be 30 plus the integral from 0 to w of r of t minus d of t equals 50. Basically, all we're doing here is trying to figure out when is that going to equal 50, and then that is when the rain pipe is at maximum capacity, and any additional rain will cause it to spill out. If you want more AP Calculus AB free response solutions, don't forget to like my videos and subscribe to my channel. You can also follow me on X at GetYourFRQOn.